recording this. So anyone who is missing out on, who wasn't able to see this, they'll be able to get the recording. So let me get myself situated here. And share my desktop. So you guys should be seeing my desktop. Is everyone able to? Cool. Cool. So we'll start out by just going over homework one, and then and then I have some extra content that I wanted to go through about just comparing different data visualization libraries, and I'll also go through project two to make sure that everyone is up to speed with what's expected there. So let's get started. I should have updated the date there. Um, so the data that we had, and I'll just pull it up in this here to more easily see what we have, but we have 5,000 companies, and we have just different measures of these companies. So we're looking at what state they're in, industry, number of employees, and revenue, etc. So so we have this information, and we had a few questions to ask. Um, so the first question is asking to show the distribution of companies uh, in the data set by state, and just simply finding out how many are in each state. So for this question, the what we're looking at is fairly straightforward. We're just simply looking at how many companies are in each state, but there is a bit more going on in terms of how the visualization is being consumed. So in this case, we're assuming that it's going to be on a portrait-oriented screen. You could imagine that being a tablet, or or a sort of another vertically oriented sort of display. And when you guys are working on sort of visualizations like this, you could think of it as it's like we're assuming it's just going to be a full screen visualization on whatever orientation screen we're looking at. But you could also you could also imagine this as being you have your dashboard, and you're putting the visualization in a cell that is specially shaped. So it's something that you'll definitely be running into as you're sort of making these choices in visualization. And I'll show some of these in my markdown here. So I don't know why it doesn't render like this when we're looking at the slides, but so this is just sort of a first cursory look at the data. Just looking at the number of companies per state, and this is really just meant to be the initial exploratory look at this. So something like a bar chart, if you're just simply looking at a count of more categorical data, bar chart is really the way to go with something like that. So here you're getting a lot of information. You're getting sort of, you could pretty easily see what the what state has the most companies, but there's a bit more work that needs to be done here. So first of all, this isn't taking into account the orientation of the screen, and when we are we just I just put this into ggplot. So the so here I wasn't ordering or anything. This is actually what I'm doing at the next one, so ignore that for the time being. But really, all I'm doing is throwing in my state by count, looking at Geom bar, and that's what we're plotting. So, again, this is meant to be a more, cursory look at what we're, sort of what we have to do. So one of the things you could see here, when you have a bar chart, arranging it by order is, a really easy way of, providing slightly more information. So here, you're able to. This is just alphabetical, and it makes it a bit hard to compare things. So if you were to, the question later on, the homework later on asks what what state has the third most companies, and using the graph as laid out here, it's a bit harder to figure that out. You kind of get it, but it's you're sort of not doing it as efficiently as possible. So arranging it is one easy way to get just that much more clarity in the visualization, as well as just flipping the coordinates. So we mentioned we're looking at a more vertically oriented screen. So looking at and I'll open that up. So when we look at our visualization, that'll display down there, and I could get this in more of the size that we want. So you can imagine it's the visualization that we're looking at. On a vertical screen, it's going to look roughly something like this. And just simply using coordinate flip, so using this this chord flip right here is what gives us the orientation that we want. So this sort of what we're looking at here, this first question was really straightforward. The really the screen size, that just sort of led to the coordinate flip, but otherwise this first question was fairly straightforward. And just one thing to note is I use a package called ggthemes. So here I'm bringing that in here, and I have at the end of my final graphs, you could see I'm just adding this plus theme Tufty. And ggthemes, there's a lot of built-in themes, so it's an easy way to sort of get to just get some styling on your graph other than the default ggplot. So for something like this, Tufty is a good way to go because it automatically takes care of minimizing the data to ink ratio for you. And you could just see what I ended up doing here. So adding the reorder and chord flip. Doing that right here. So for question 2, we're digging into the state with third most companies. What did everyone come up with for which state we're looking at? New York. Yep. So, and of course, looking at the graph in this way, it's easier to pick out New York as the third most. So we're looking at a single state, and in this case, we're imagining that we work for the state, and we're looking at employment by company, by industry. And the things that we're looking at, we want to see either the average or the median employment by industry. But more importantly, we want to see how variable the ranges are. So this sort of question is a bit more complicated. We have the data, each record is a company, and we're asking questions of each industry. So there's, there's more going on when when we're looking at the question in that way. And because we have multiple companies, we we have this additional information of the within an industry and within New York what the range of employment is. So you could see, we're looking at that here. So what does it mean to be interested in how many people are employed? We have multiple companies, and there's sort of more information there. So Albina asked, and by the way, I'm recording this, so that's why I'm repeating the chat. Albina asked about what I meant by deal with outliers. I'll get into that. I'll get into that in a bit as we're looking at this question. There are a few ways of dealing with outliers, and for my solution here, I sort of stuck with one option of dealing with them, but I'll sort of show that there's a few different ways of dealing with it, and for this data set, there's not really sort of a right way or a wrong way. So yeah, I'll get to that in a bit. But starting out, when we do have this sort of data where we have data by industry, but we're looking at company level records, a scatter plot is a good way to just get an initial feel for the data. And so as a first step in exploratory visualization, this is always a good step. And one thing we see right at the outright is we have it does appear that we do have an outlier problem. So we have two companies, one with 10,000 employees, one with over 30,000, that are really skewing what's happening. So looking at the scatter plot, if we wanted to, we're really losing information about the distribution of companies because of these outliers. And you can see here, I'm just simply throwing that into a scatter plot. So there was nothing special going on, just having industry versus employees and looking at geom point. So what I ended up doing here is I just simply clipped the data. So I'm simply taking these points where we have large numbers of employees and setting a max number of employees so that we're able to get more information about the distribution of companies. So there's actually 3 companies that are affected because what I chose is 2,500 employees as where I'm clipping it. And it does indeed give us more information about the ranges of the companies. So while it does give us that, there's still, one could make the argument that there is still an outlier issue. We have this sort of cluster of companies here where we have large numbers of employees, and while we have more information about this distribution, it's we have more than we had before. There's one could make the argument that we could perhaps we perhaps may want to see more information about what's happening here. And what this is kind of telling us about the data is it's telling us about kind of an overall distribution of employment at these companies, and so in terms of the distribution, like does anyone have an idea of what you would call data distributed in this way, or what you might be like? I didn't. And Chun-Hui wrote in the chat that you were removing, you're removing the top 5% from the head and the tail. So that's more similar to what I was doing. Scale continuous, removing the data. So this question, it's more about sort of what the coordinate Cartesian. I actually haven't. Yeah, Albina, I'll have to check out. I'll have to check out your assignment there. Unfortunately, I haven't had a chance to grade the assignments yet, but that'll be coming. Tomorrow's probably going to be my grading day, so I'll get all of that back to you. Um, yeah, coordinate Cartesian, I'm not knowing off the top of my head, but so basically, the data, the data that we have here, we clipped some of the data, and it still looks like we might potentially have an outlier problem. And although it is better than what we had before, it's better to have you know larger number of companies with sort of higher number of employees than have one or two data points that are skewing it. Um, but what this is telling us about the data is it's exponentially distributed. So like I could, like one of the things, like as you're dealing with outliers, you could do this in an iterative way where, you clip some of the outliers, visualize the results, see what happens, and perhaps clip again. So one thing I might want to do is, set a clip for, maybe half here, set it for like 1250 and, set these five, these six companies as outliers. And if I do that, and I don't have that visualized, but, you would probably end up with something similar looking where you have, a lot of, you still have companies clustered towards the lower end of the scale here. And that's pretty common of exponentially distributed data. So you could you could iterate like this. You could do this multiple times, and you'll keep on running into that same problem. And that when if you truly had data that was even more exponentially distributed. So if I clipped these companies and I only had one or two companies showing up here and the rest really still clustered towards the bottom, which does sometimes happen. You could like that's really when you don't want to continue clipping your data. Like here, you have you're still able to see differences between the industries. So you see that IT services, as an example, has more variability in terms of employment than food and beverage, for example. So, and again, this is, there's no right or wrong answer for what I was choosing. I just did one cut and decided to leave it at that. But if you are, if you chose another way of dealing with this, that would be equally valid. So if you do have exponentially distributed data like this, what would the way to deal with that? What's one strategy of dealing with that other than clipping the data, like I mentioned? Yep, exactly. So June and Albina got that with transforming the data using, in particular, a log transform. And what this really gives us is, it'll show, it'll essentially show the variability in, that's happening in sort of, low, sort of this large group of companies with low numbers of employees. And something like this, I would say there's a trade-off there. The trade-off really is if you choose a log transform, you end up losing the sort of intuitive, link between the scale and the data. Like I mentioned in the lecture in our lecture 2 weeks ago, when you are dealing with this sort of positional data, so you're able to pretty easily see that, this company has, a little bit less than twice the number of employees as this company. You're able to, pretty easily find that out, and you lose that intuitive view when you're using a log scale. And Chunhui mentioned in the chat, Albina as well, that they used box plots, and So this is just showing what I ended up doing to clip the data. So I'm just setting my top and bottom here. But you could see box plots really were sort of the way to go with this sort of data. So box plot, yeah. So whoops, sorry. Yeah, so a few people are mentioning, you're still removing the outliers. So I'm still, I still clip the data to show this box plot. But absolutely, like, the box plot doesn't really end up working with it doesn't end up working when you have those large outliers, because you end up with just every single box plot looking as cramped as these are. Yes, Chunhui, after we go through this, I'll give you a chance to show your homework. Interesting. So Peter mentioned in the chat that the box plot you found was too busy. I have another example of a visualization type that is less busy than a box plot. But one thing I wanted to mention about box plots versus using a scatter plot, and I actually wanted to relate this to what we've been talking about in our discussion so far. So we've so far we've gone through maximizing the data to ink ratio and avoiding chart junk. And so in particular, you could sort of see this as an exercise in in sort of the decisions that come up with the data to ink ratio. And I noticed it more in section 1 than with you guys, but some of the discussion, some of the students in the section 1 discussion board, there was a surprising number who were questioning whether it even makes sense to maximize the data to ink ratio. You sort of look at that as something that sort of should we be doing that, or should we be that cavalier with chopping out sort of graph elements? And one way that I think you could look at the choice of maximizing the data to ink ratio is it's a trade-off. So each chart, you could almost take a look at a visualization, take a look at each individual chart element, so things like ticks, the grid lines, etc., and evaluate it in terms of how much information that grid element, that chart element is providing. And what you'll find is there are some chart elements that aren't showing that are more efficient than others. So some chart elements may not be providing as much information. Some chart elements are. Almost all chart elements, aside from true chart junk, are showing some information. And the question really becomes a trade-off. You sort of try to look at less efficient chart elements and think, am I okay with sort of taking away this smaller amount of information, with the benefit being I free up, I sort of get a better data to ink ratio. And so, looking at a scatter plot versus a box plot you could actually see as a less, sort of a, it has a better data to ink ratio. So each of, with a box plot, we're seeing the interquartile range, we're seeing the, I believe it's 1.5, I always forget the whiskers. I think it's 1.5, the interquartile range. But you're getting whiskers to show more information about the distribution, but you're losing, sort of the full distribution that you get with a scatter plot. So, if I wanted this scatter plot to look a bit, more professional, I could, maybe add a jiggle with the points. So it's, so we're seeing, so we're able to sort of, not get points bleed into each other. But, with these points, you're able to see more information than you are with a box plot. So, with telecommunications, for example, you could kind of make out there's a slightly bimodal distribution, whereas with a box plot, you end up losing that information. And, you sort of view the question not as, maximize the data sync ratio at all costs, but it's more a trade-off of, what, like, evaluating your chart elements, trying to find out which chart elements are efficient, which ones aren't, and, sort of evaluating on a case-by-case basis, is it worth it to cut the less efficient chart elements? And June mentioned they removed 10% of the companies. So yeah, it's exactly, you lose some information there, but you're sort of getting a bit better of a view there. And so one last thing to do with with the box plot. So here, this is just dealing with the outliers. And here you could look at it, in a similar way, like sort of looking at kind of, the concept of like, trying to be smart with chart elements. Here we're, sort of smartly applying labels. We could have just as easily, added labels to every single point in a box plot, in a scatter plot rather, but that would obviously be way too busy and would detract, it would technically be more information, but it's just so detracting from the readability of the chart that, it's not worth it at all. But it's worth it to be smartly applied to outliers, to sort of show that, you have larger numbers of employees in those companies. So this is another option for showing this sort of data. And yeah, so Chunmei mentioned the mean of the box plot can show the high density of the group. What exactly do you mean by that, Chunmei? Oh, median. And how does that show the high density, the mean? Or median?
Hey, sorry.
Yeah.
I just you mentioned the scatter plot. In the scatter plot you can see the dots continue, and high density in the lower number employee. So and when the data is going up higher, we can see not that much company has that much employee. But I want to say that in the box plot, you can see the median and mean. The line can show you that the mean, that means the high density of the most of the company has the number of the employee in each group, so that it can vary. Even though the box plot has a longer scale, but you can, for example, in the first industry, you can see that we have in the box plot we can have like a longer body, but the mean is very low. That means, that means the high density. So a lot of the companies in this industry is not that much employee in the company. So this is why I mentioned that.
Exactly, and that's a very good point. That when that when you see, because a box plot, it's meant to show the and Chunhui is mentioning what the so it's the first and third quartiles and the median. And what this is really giving you is a essentially discrete look at the distribution. So and you're
Yeah.
absolutely right that what that means is you have more of a it sort of tells you that information about the distribution. Cool. Um, and yeah, and one other thing I wanted to show here is point ranges are even a more pared down way of showing this sort of information. So, box plots, you have your X and Y, and that works right out of the box. But you could also create custom visualizations that may show what you're interested in. So for something like point ranges, we may want to, as like I used as an example here, we may want to highlight the mean, not the median. It's for data like that, and actually especially for data with more exponential distributions, you don't want to, you want to show the median because it gives you more information that the data is skewed. Like if you have a lot of high values, that'll skew the mean and make the data itself seem less skewed than it actually is. But if for whatever reason you wanted to show the mean, you would be able to, map out points for each of the means. And here this is even more pared down than what we had before. All we're showing are these whiskers. And what I actually did, like I just based the whiskers on the standard deviate. Oh, I actually used quantiles. I thought I used standard deviation. But yeah, you can see I'm looking at the lower and upper quantiles, and using that to show these distributions. And then one last way of doing that, you could also just add error bars to a bar chart. So for something like this, it's just simply a bar chart, but you're adding this geom error bar, and that sort of gives you information about the medians or means, but also gives you that much more information about the distributions. So for question 3, it was pretty similar, and really, could have been treated in a similar way. So, here we're now imagining we're working for an investor, and we're trying to look at which industries generate the most revenue per employee. And once again, we want to look at the distribution per industry. So for something like this, and I didn't, do any processing with this box plot. Like a box plot could definitely, show you the answer to a question like this, as long as you deal with the outliers. And as you can see here, this is just adding geom box plot. But one additional way of looking at information like this would be to use density charts. And this is also, another form of density plots is a violin plot. So, a violin plot, it's actually the same method of doing a kernel density, but it's made to look more like a box plot. So here, this is just yet another way that we could view the distribution, and this is useful because it actually gives us a lot of bang for our buck in terms of a data to ink ratio. So we here we're actually getting almost as much information as we would with something like a scatter plot, where you're able to see the individual points. And so this gives us more information about the about what's actually going on with the distribution. So you'll see things like wider distributions or more narrow distributions, and those will show up as either wide or narrow boxes. But we're also getting more information about what's happening inside the distribution. So for real estate, for example, you could see that there's a bit of a bimodal distribution going on. You have sort of a number of companies out here. You have this distribution down here, and you sort of see that happening with, or I'm sorry, that's insurance, and you sort of see that happening with security here also, where you have some interesting shapes going on there. So and also something like this, the density charts, it's just simply a line. So we're really being economical in terms of the data to ink ratio. And ggplot, it has its own geom density there, and I'm just simply using facet wrap for that. So for a graph like this, there are few trade-offs in terms of the data to ink ratio. The only one I could really think of is, because we're using facet wrap, like we're able to, you could imagine using a violin plot for something like this, but it might be too squished together if we're just looking at it in one dimension. But a facet wrap, we sort of lose, you slightly lose comparability, although it's not even losing that much. Like there's not much being lost by a choice like this, and you just by sort of laying it out using facet wrap, you just get that much more of a clear view of the distributions. So that's it for the first homework. Albina, so uploading it to GitHub is sufficient. If you can, though, and if you can, just include a link to the GitHub in the assignment in Blackboard, and then just submit it there. So GitHub is actually preferable to having to try to download it from Blackboard, but like Blackboard just serves as where the grade lives. So just put the link there. So any other questions? And then Chunhui, we could make you presenter so you could show off what you did. So are you ready for that? Cool. Cool. So I'm going to make you presenter, and you should see a button that says play.
Yeah. Can.
Yep, and I could see see your desktop.
Good. Yeah. Yeah, this is my first homework, the question one. Oh, can you hear me? Anyone?
I can. Yep, we could hear you.
Good. Yes. I use the chord free. I have a question. So I use the chord free, but it still look like more wide than high. I don't know why. That one I don't figure it out. I usually like to add some number for that. But let's focus on the question 2.
Yep.
Yeah, I use this function, the scale, and which I put in the y-x. So I put y and it continues, and here I put a quanti. I put a variable, so which I want to remove 5% from the tail and the head and tail like that. Yeah, like Professor said, that it's a trade-off. Yeah, I very agree with that. But yeah, but after I removed some part from the head and tail, so the graph is more clear. The small thing that starts to showing a little light at the median, and the range of the box, we can see it a little bit from here. Yeah, that's what I try to share. That's it. The number 3 is similar, like what you said, using same thing to remove the outliner. I think that's it. Yeah. That's it.
Yeah, yeah, and that's a really great strategy for you know, really, you know, get it like, and actually by doing that you could see that Chenhui's box plots and I'll take that presenter myself. Chunhui's plots are actually you know, you're getting more information than you were with my plot about the distribution. And yeah, Albina, you're right that it, you know, removes the data, so it's, you know, affecting the metrics themselves. So it is, you know, it is a trade-off. You know, and one, you know, depending on what you're looking to do, depending on what you're looking to do, you could, you know, sort of make the argument either way. So if you really just want kind of a summary of the distribution, so the sorts of questions you're asking, and actually for the investor question, you know, really the investor question, like I would argue a continuous scale like this approach, it would be more useful, because if you're an investor, you know, you're worried, you're thinking about, you know, I'm an investor, I'm looking at a company in a certain industry, and I'm interested in what the, you know, average return per employee is, but as an investor, I'm also, you know, concerned about risks. So I'm concerned about what are the chances that, you know, what's the upside, you know, sort of the upside, what is the chance that, you know, a company could go gangbusters and, you know, I make huge returns, or on the flip side, what is the chance that it could, you know, just totally collapse? And, or, you know, so for something like that, you want really that variability, and, you know, it gets you there in a more efficient way to, you know, remove the top 5% than the low 5%. Of course, you could also make the argument that you know, leaves you not totally aware of, you know, true black swan events. But you know, I would say that, you know, that gets you the, you know, information about you know, what you'd be looking at for in terms of investment there. So thank you, Chunhui, for volunteering to show that off. And any other questions on this homework before we move on to previewing homework 2? Cool. So homework 2, we're doing a few things. We're, you know, this is meant to, you know, go through visualization in a Python environment. So we're using a Jupyter notebook and, you know, displaying our information using Jupyter. But we're also dealing with a large data set. In this case, we're looking at what's called the Pluto data set. And Pluto is essentially data about every single tax lot in New York City. So definitely something that, you know, large enough that you'll have to think about, you know, how you want to visualize it. So, you know, I included the link of where you could find Pluto here. You'll be able to just download a zip file of the CSVs and sort of look at a data dictionary to answer any questions you may have about the data. And I, you know, just unzip it in the same directory, and, you know, you should be able to just reuse the code and read it in. In terms of, you know, uploading this to GitHub, don't worry about uploading the CSV files, because you'll probably get large file warnings, and GitHub will get mad. So so don't get too concerned about that. So I'm just getting rid of some outliers, concatenating everything into a single data frame. And when you, and actually I ended up including this for getting the latitude and longitude, but if you're unable to get this running, don't worry too much, because since we're using Datashader, the X chord and Y chord should give you pretty much the exact same thing. So I just sort of needlessly added all of this. But so what we're doing for part one is sort of trying to look at what one does when you are visualizing large data. And binning and aggregation is really the most common strategy for dealing with large data sets. So if you think about like different types of visualizations that do this automatically, something like histograms and heat maps, histograms, heat maps, box plots, they do this sort of aggregation as well. It's, for these sorts of visualizations, it's inherent in the visualization type what it's doing, but really any visualization type could be representative of these sorts of actions. So, looking at a line plot like this, it's, a line plot could be any XY data, but what we're actually looking at is we're binning it by year and we're aggregating it. We're just simply getting a count of the number of lots built. And you could sort of see, the Pluto data set, it's not the cleanest data set. So part of what you'll need to deal with are some of these quirks. And so one of the quirks is, for some reason, we have all of these spikes going on. And, there's, as I say here, you'll need to, part of the assignment is going to be finding a way to deal with the, potentially these potential problems with the data. And I just included some notes on pandas because I know this program focuses a lot on R, and this is just sort of what I found a useful cheat sheet for what I thought would be useful. Like, these are the sorts of things that, as I was sort of working with pandas, like I found I would have found useful to have been told. So for the first question, we're just dealing with kind of more manual, sort of manual aggregation and binning like this. For the second question, we're using a library called Datashader, and Datashader is really, it essentially does away with the need to bin data. So what I was mentioning, before, a lot of times you need to think about what you want to do in terms of binning. So you think about the sort of question you're asking, and you sort of let that guide how you bin and aggregate your data in order to answer it. But for something like Datashader, that's really more comparable to, you just throw it at, you have a scatter plot as the most common example. You plot out your scatter plot as if you had a reasonable amount of data, and Datashader automatically deals with the the data for you. So here we're, as an example, we're looking at year built versus number of floors. So the second question, so this is sort of a comparison that we could make, bringing it over from the first question. And the more traditional way of dealing with this is just simply using a 2D histogram. So here I'm just creating a Plotly heat map that is, giving me information about this distribution, and it shows it, but it's subject to biases. So this notebook here that goes through plotting pitfalls, this is sort of a nice way of looking at the inspiration for a Datashader, where and you guys may have run into this before in your own plotting, but here the choice, you have two categories of data, and the choice of which plot you're sort of putting on top, it shows a vast difference in what you end up looking at, what your visualization ends up looking like. And if you look at, there are ways of sort of getting around that. So you could make your plot sort of you could change the transparency, and you end up getting a bit more truer to what's actually going on. But you still have slightly like this is a bit more purple, this is a bit more red, and it's so there's still not entirely it's still not entirely truthful in terms of what the underlying data is. And similarly for just making the data pinpricks, you lose some information about it's harder to see the individual points. So and this goes through a bunch of these sorts of pitfalls. So here, this is sort of the undersampling issues that you could run into with heat maps as an example. And Datashader just takes all of the, it deals with all of these problems for you, so you don't have to. So all I did here, and there's, this sort of, there's a link to the, where is it? Visualization pipeline. So it kind of shows you, the visualization pipeline shows you what's happening with each of these, steps. So you have your definition of the canvas, you have the points that, you're sort of aggregating. So here we're looking at, year built versus number of floors. Your shade, you sort of have your shade step and then export. I included as much sort of, background of Datashader, but it's still a relatively new package. The actual documentation that Anaconda has, I found wasn't the best. There's a lot of examples. I included what I found was the most useful YouTube talk. So there's a link. There should be a link to a YouTube talk here that shows that intros Datashader. But if anyone has, if anyone finds anything else, feel free to post that in the forums. This was sort of the most that I found with a newer package like this. And so here you could sort of see, where Datashader really shines with this sort of geographic data. We're plotting just latitudes and longitudes. We just simply threw all of our data points at Datashader, and it automatically found a smart way of showing this. So it's, where we have enough resolution to show individual points, it shows those, and otherwise it's shading in densely packed points to, get something that looks similar to a, that looks similar to like a heat map. So, we're able to sort of see where, like, we could sort of pinpoint neighborhoods where there's a large number of, densely packed single family homes. It's why neighborhoods like Upper Manhattan and the South Bronx, and even Midtown, you see those are more, taller apartment buildings where you have like, and one apartment building would be one tax lot. So it actually shows up as less dense, whereas, Northeast Bronx, Southern Brooklyn, you have higher concentrations of smaller lots. So those show up as more densely packed. So I'll sort of look at, one thing I want to do is sort of look at a, sort of simpler example of what this question is asking. So for this question, we're looking at the common, we're looking at two measures. We're looking at the assessment of land and the assessment of the structure. So let's just assume we're looking at the land assessment. If we're looking at that and we wanted to, plot out what the, plot out with something similar like this. We wanted we wanted to also shade our points by the value of the land. Can anyone see a potential problem with trying to ask Datashader to do that? So here we have our, we have sort of our just points simply mapped out and shaded by the density. If we wanted to shade it by the value as well, can anyone sort of guess at why that might be problematic? Okay, so when we are looking at this plot here, we technically have more information being conveyed than you might initially think, given the fact that this is a scatter plot. If you just have a scatter plot, all you're really looking at is your x and y. You're simply looking at your position. But here we have an additional, we have sort of the additional information of density being shown. So you could almost see this as we have our variables for latitude and longitude, and we also have a numeric scale for the density of buildings being shown. And what I was asking before was, what we're looking at is the value of the land. And so what I'm technically asking is, we want these two continuous variables to be shown like on the same color scale, and that is kind of problematic. So if we like we have this already being colored by by density, and there's no real good automatic way of dealing with another continuous variable. So what we actually have here, and what I linked to in this question, is I made this less like homework 1, where in homework 1 there's sort of more interpretation in terms of which visualization type you're choosing, what sort of goal you have. There's kind of more leeway and sort of more choice there. This is really meant to be more prescriptive. So this really this exercise, I just wanted everyone to try a real world example using Datashader. And what we're looking at is a bivariate choropleth. So, and actually before I do that, before, if we're looking at land value, we're looking at two continuous variables, and they're sort of in conflict with each other. So unless you're sort of specifically choosing, like you could imagine trying to come up with an algorithm that smartly does these sorts of bivariate stuff, sort of bivariate choropleths. But barring something like that, you have two continuous color variables that are not really able to be viewed at the same time. What Datashader can work with is categorical data. So in the US Census example, we're looking at, basically there's a point for every, like they sort of took a representative sample of the American Community Survey. There's a point for each person. Each point is associated with a latitude and longitude, and we're able to get a similar density map that we were getting with tax lots. So here we're able to and to varying degrees, they sort of show different strategies of dealing with dealing with this, but what we're getting is a heat map of population. So you could see the cities as an example, as where most people are living. And what this is, so as you scroll down here, what this example is showing us is, it's showing us looking at this survey data with the sort of across the categorical variable of race. So we have a discrete number of races, and we're able, Datashader is able to deal with that. You have one, and the way that you could actually look at a graph, sort of a visualization like this, is you have one continuous variable being the density of population. You have one categorical variable, which is race, and you're sort of looking at those two together. And because you have differing types, Datashader has an automatic way of dealing with that. So this is sort of harkening back to what we were looking at over here, where you have, like, technically you have a lot of things going on here. You have overplotting of different categories. You also have just simply the large number of points, and Datashader deals with that for you. So sort of mapping that back to this question, what we're actually looking at with these bivariate color scales is we're essentially taking, in this case, two continuous scales, and we're turning that into a single, from Datashader's perspective, a single categorical scale. So, if we're looking at, and this is a pretty cool read, just looking at what this guy was doing, he sort of makes, a sort of takes these two continuous variables, bins them, so he bins them 3 each, and we end up with this sort of 9-cell, more categorical representation of the data. And that's what we'd be mapping out for this question. So, really that's what that's asking here. A bit more prescriptive, but really meant to give everyone a chance to play around with Datashader. Datashader is it's a really cool library. The fact that it's doing all of this automatically for you. So, any other questions on homework 2? And if there are any questions, feel free to go to the Ask the Instructor forum, or I just realized I didn't add it yet, but I'll add a Project 2 discussion forum. So you could just go there and specifically talk about the assignment. Albina. It's I mean, I won't be like taking off points for not posting by Thursday, but it's really helpful just to allow the conversation to progress as the week goes on, because in addition to the discussion posts, you guys are are also responding to each other's posts, and posting by Thursday just allows people to have time to respond. Whereas if you post on Sunday, you're not going to get that. So, I mean, if it becomes an issue, I'm hoping it won't become an issue. But if but it's not like if you don't get a chance until Friday to post, don't worry too much about it. Any other questions? Cool. So the last thing I wanted to go through is this is just some sort of a way of comparing visualization libraries that I found is pretty useful and kind of speaks to really the pros and cons of these different libraries and how they fit into an overall sort of business intelligence pipeline. I mean, a lot of data visualization, like we there are lots of different ways that you could talk about that. Like, we last lecture we were really talking about strategies for the actual visualizations themselves. But as the course progresses, you'll hopefully be seeing data visualization as really kind of when you run into this in the real world, you're sort of thinking of a sort of a, what I'll call business intelligence pipeline. You have data, you have some sort of business problem. So perhaps you have data that's coming in every week, and you want to keep track of it using a dashboard or something like that. Or on the other side of things, you're doing more ad hoc visualizations. You have a new data set and you're just simply feeling your way around it. So looking at it in this way, I'm sort of framing it on a scale that leans from being more data centric to more visualization centric. And along this scale, there are trade-offs. So things like so far you've used ggplot for Plotly for Python. And actually Plotly for R, it's a bit more similar to ggplot because the R developer wanted it to map more closely to ggplot. But Plotly itself, like JavaScript or Python, is a bit more towards the middle. Where so as an example, if you wanted to make a scatter plot with different types of categories, so you wanted to have different colors for different categories, ggplot allows you to just include that in the AES. So you would be able to just say, in my aesthetics, X equals, whatever, Y equals whatever, color equals, what my categorical variable is. And ggplot just does it for you. There are a lot of packages that will sort of do the aggregations for you, and sort of link it more with your data model. And like something like Tableau, it's sort of brings in the aggregations along with your visualization types, and it's pretty intimately linked to the type of data that you have. And the pros of this is if you have assuming you've cleaned your data, it makes it very easy. If you're in a tool like Tableau, it's pretty simple to just sort of pick how you're aggregating your data and sort of map that onto whatever sort of Tableau dashboard you're creating. And then looking at the other side of things, using Plotly Python as an example, if we wanted to do the same thing we were doing in ggplot, sort of having our scatter plot divided by different categories of data, it's slightly different because what you're doing in Plotly is you're adding each of these as an individual trace. So what I would probably do is create a for loop that is adding these traces to a data object and create sort of your traces that way. So that's sort of one step removed from the just just coloring it by your aesthetic with ggplot. But one of the benefits that this brings you is there's a bit more flexibility. So with Plotly, I found that it's a bit easier to deal with multiple sort of multiple trace types within a single plot. If you wanted to have points that are showing up on a line plot, for example, the concept of adding each trace individually makes it easier to do that using Plotly than it might be with ggplot. So you sort of have some benefit to being slightly less abstracted. And Albina is mentioning she found it useful to arrange data and plotting all the columns. What do you mean by that? Plotting all columns?
So basically, instead of defining each trace separately, you get, well, something I guess similar to what you were saying, using the for loop, but you basically just do it with one object. I don't know if I used the terminology correctly, but you would just say for, use all of your columns and basically plot each one of them, essentially.
Yeah, so you're absolutely right about that. So I like I was more assuming that you had your categories in so you have let's say you have an X column, a Y column, and a category column, and that, like, if you have 4 different categories, you'll have 4 traces. And another way of working with that is essentially, and this works better for some types of data than other types of data. You could have one column for each of your categories. So let's say you, I'm just totally blanking on a good example here, but you could, yeah.
So no, I just was gonna say, so in my case, for example, the example that I was referring to was time series data that had multiple, let's say, departments, multiple departments with values for each department, right? So instead, I would arrange departments in columns. Each department will have its own column with values for a specific date, for example, and then I would be able to plot them all instead of specifying each trace for, okay, X and Y, X is date and Y is value. Instead, I would just specify that X once, and then using for would like plot all of the values, but it would give individual line for each department, for example.
Exactly, and that's a really good example of that. Where you have sort of different measures in your columns, and each one of those columns is a trace. And you're right that makes it easier to work with in Plotly. And actually, by the way, one thing that this is reminding me of to note for homework 2, for the first question, I used Plotly for that, and that's kind of what I was recommending. But if you guys are more comfortable in Matplotlib or something like Seaborn or another library, feel free to use that. So I don't mean to sort of, this is meant to be more visualization in Python itself. So there are there's no, with Python there's no kind of ggplot. Well, there actually is a ggplot port, but there's no sort of comparable kind of elephant in the room as ggplot. There's not a sort of obvious visualization library to choose. So for Python, feel free to use something else if you're more comfortable with it. So for visualization, types, like you sort of, for individual visualizations, you sort of have this. And then for looking at, as we get into Shiny and Dash and D3, you have a similar trade-off, when you're working with these sorts of environments. So something like Shiny is very highly abstracted from web development. There's a lot of different UI elements that are sort of Shiny specific. So things like fluid page, sidebar, all of those are abstractions that are meant to make sort of make Shiny easier to use. We're actually at Plotly, we're actually in the process of making that more easier with Dash, but Dash as it exists now is fairly low level. So you'll as you get and this is assignment 4, but Dash is linked to essentially HTML tags. So you could have a P tag or something, and you're able to access that exact tag. And it's, it's abstracted in terms of it's Python, but it's just that much more low level. And then D3, that's you're in JavaScript, so that's at least for our purposes, that's pretty much as low level as you could get. And once again, for each of these, there's trade-offs. So, looking at like data-centric stuff, like when it works, it just works. They're elegant solutions, but you sort of lose a bit of freedom in what you could do. On the viz-centric versus, and I'm sorry. So yeah, for something like this, you have like for Shiny, there's there's an ease of use there, but I've even noticed this like comparing Shiny with Dash, that you having access to more lower level things with Dash allows you to sort of deal with problems that you aren't really able to solve using Shiny. So it's a trade-off, like that ease of use versus power. You could almost think of it as. Whereas with D3, you have the power to do anything that you're doing in JavaScript. So you have that real low level power. Anyone have any comments on this? Cool. So that'll be it then. So thank you everyone for coming. And if anyone has any questions, reach out to me via email or in the Ask the Instructor forum. But good luck with homework too. Datashader is a fun library, so hope you guys have fun with that. All right. Good night, everyone.